So look at the diagram. The circumference of a circle is just the distance round this circle. Besides, a circle is just a collection of points equidistant from a fixed point. So if you have some points, collection of these points equidistant from this fixed point. The fixed point is this center O. So if you collect those points, you form a circle. So a circle is just So look at the diagram. The circumference of a circle is just the distance round this circle. Besides, a circle is just a collection of points equidistant from a fixed point. So if you have some points, collection of these points equidistant from this fixed point. The fixed point is this center O. So if you collect those points, you form a circle. So a circle is just a locus of points or collection of points equidistant from a fixed point. So once you collect those points, you form a circle. Circumference of a circle is just the distance round that circle. Why the radius is just the distance from the center to a point on the circumference. So I'm saying that OA, that's OA here, is the radius of the circle. Why the diameter is 2 times the distance from 2 points on the circumference that passes through the center. So if you have, so I'm saying that AD is the diameter because the distance from A to D passes through the center. So AD is our diameter. So AD is the diameter. Saying that OA or AO, AO is the radius, while AD is the diameter. So arc, we have major and minor arc. So the minor arc is like AB. AB is a minor arc. This is a minor arc. So I'm saying that AB is a minor arc. While ACB is a major arc. So ACB is what? A major arc. So the one that contains the, if you look at angle alpha and angle beta, so this one is smaller than this, so this AB is our minor arc, and we normally represent it as AB with something on top like this. It's denoted by this Y, the major. So major has three letters, Y minor. That's how you know the major and minor arc. So coming to sector. Sector is just a portion of area of that circle, because area of a circle is just this portion. Everything here is the area of the circle. So just a portion of that is the sector. So I'm saying that area AOB is a sector, but it's a minor sector because it contains the minor and the smaller angle, while the major one is the one formed by beta. So that's the minor and major sector. With that, you can easily see that the area, since we know that circumference of a circle is, let's now write the formula for the length of arc and area. That's area of a sector. So since we know that circumference of a circle, we've known that of a circle is always 2 pi r, or maybe pi d, because we know that d is 2 times r, diameter is 2 times radius, and we know that area of a circle is always pi r squared, or maybe in terms of diameter pi d over 2 squared, which is pi d squared over 4. So it's either this or this. And since arc, length of arc, now arc is a portion of the circumference. So we now see that since the angle formed by this arc, minor arc, is alpha, so we see that the length of arc is alpha over 360 times 2 pi r, just a portion of the circumference. So that's for arc AB. But for arc ACB, that's the major one, is beta over 360 degrees times 2 pi r. And you know, beta could be written as 360 minus alpha. So in most cases, they won't give you beta, they might give you alpha, minor arc. That's the angle for the minor arc. So anyone, this alpha. So that's the formula for length of arc. Why area of a sector? A sector is a portion of a circle. So we still have it as, if it's for minor sector is alpha over 360 times pi r squared. But if it's for major sector, the big one or the bigger one, we have beta over what? 360 times pi r squared. So coming to segment, a segment is inside a sector. So see what I'm saying? So we have the major segment, we have the minor segment. So you can easily see that if I want to get the minor segment, is just subtract this triangle. So assuming I have triangle, I have a triangle with radius, that is a circle with radius r that formed a triangle. That's the chord and the length of chord and the radius form the triangle. So what you have to do, you subtract the area of this triangle from the sector, you get the area of a segment. So I'm saying that the area of, I'm using the minor segment now, is, okay, assuming I have the angle here to be maybe alpha. So alpha over what? 360 times pi r squared. This is the area of a sector. I told you to get the area of a segment is area of a sector minus area of the triangle AOB. So that's what I'm doing, minus area of this triangle is, remember, this side angle side, so it's half r squared sine alpha. Do you remember, if you are given two sides and an included angle, the area of the triangle is half times the product of the two given sides times the sine of the given angle. So that's it. So that's for minor segment. So if you want to get for measure, it's very simple. For measure is just the area of a circle minus area of the minor one. So once you've known the portion, this minor one, you subtract the area of the minor segment from the area of the circle, you now get your area of major segment. So that's it. So let's go over to length of chord. So a chord is just the distance between two points on the circumference. So we can still see that a diameter is a special type of chord. So assuming the length of this chord is L, so AB, want to get the chord length of this chord. So we join the radius. As you can see, we form an isosceles triangle. And you know one characteristic of an isosceles triangle, the height is a perpendicular bisector. So it has bisected the angle theta to be theta half, that's half theta. So our main aim is to get the L, that's an expression for L. So from this you can easily see that in triangle OCB, that we are given the hypotenuse and we are given the opposite. So we see that sine half theta is opposite, which is L over 2 over what? Adjacent over hypotenuse. So which is the same as L over 2R. Therefore, making L, which is length of chord, L is the length of chord, is now 2R sine half theta. So that's the expression for the length of chord. So each time you're asked to find the length of chord, that's the formula you use: 2 times the radius times the sine of the half of the angle, central angle, the minor one. So that's it. We are given the diagram and we are asked find the minimal length of the rope that will go around the 3 circles as shown. The radius of a circle is 2. The answer, without wasting time, is we have 1, 2, 3. 3 times 2r plus 2 pi r, where r is the radius. So we have 6r and r is 2. So we have 2 pi 2. So our answer is 12 plus 4 pi, option B. So you'll be wondering, how come I solve it very fast? Okay, I will first locate the centers of the 3 circles. So see the center of this one, center, and if you join the centers
if I join here to there, we see that this is the radius. If the radius is r, so from here to here will be 2r, as you can see. So that same way, here is 2r, joining this to that, r, and the same way r. So that's how I got this to be 2r. So the length here is always 2r, and we have 3 of them, so that's why I multiplied by 3. Coming to this part, remember we want to get the length of the, we've gotten this side, remaining the curve, that's the arc. From here to here is for this part, remaining this part, and from here to here is the same thing as here. So if you move this to this, we've covered here. Finally, from here to here is covering here. So automatically that's the circumference of the circle, which is 2 pi. So it's very easy. We asked find the minimum length of the rope that will go around the 4 circles as shown. The radius of a circle is 3. So the answer is just 1, 2, 3, 4. We have 1, 2, 3, 4. So 4, 2r plus 2 pi r. And the radius they told us is 3. So we have 4 times 2 times 3 plus 2 times pi times 3. So the answer is 24 plus 6 pi. Option D. You'll be wondering how. Okay, let me just explain. It's very simple to understand. So let me first locate the centers of the circle. If you notice, I counted 1, 2, 3, 4. That the length of each is 2r. How did I get the 2r? If you join the centers, you see that this radius, so automatically this is 2r. That same way, they are all 2r by joining their centers. So coming to this is just the circumference of this circle. Yes, because we've gotten the straight part of the rope, so the curved part now is the circumference of the circle. Yes, because you see that for this covers that. You see that here covers from here to here, while here starts from here to here. Do you get? Finally this part covers here. So this curve is just a circle, 2 pi r. So that's the answer. The answer is option D. Whereas find the minimum length of the rope that will go around the 4 circles as shown. The radius of a circle is half. The answer is, I have 1, 2, 3, 4. So 4 times 2r plus 2 pi r. 4 2r is half plus 2 pi half. So our answer is 4 plus pi. So that's option D. You'll be wondering how come I solved it very fast. Okay, it's just very simple to understand. Let me just locate the centers of the circle. So once we join the centers, you see that this is the radius, this is the radius. So this is 2r. So that same way, here is 2r, 2r, 2r. So that's why I counted that for each 2r. So coming to this is just the circumference of a circle. And you see that each of these is just we've gotten this part, remaining the curved part of the rope. So you see that each of them, if you join the 4, to be a circumference of a circle. As you can see, if this for the first one, if we bring this to this part we've covered here, if we bring this part, we've covered here from here to here. So finally bring it covers here. So this is just the circumference of these 4 parts. So that's why it's 2 pi r. So the answer is very simple, option D.
Okay, we are asked to find the area of a square that is in the diagram given these 2 shaded regions. They said in the figure, square EFGH is inscribed in the circle with center O. If the sum of the areas of the shaded region is 10 pi, what is the area of this square? Okay, you know, from our basic geometry, square, the sides are congruent, they are equal. So if we call the side length x, so let's call here x, this x, and you know this is square, so each of these is 90. So making, if you add the diameter, okay, if you join E to G, we have the diameter. So if we call the radius r, so radius of this circle is r. So we now have a right triangle, a 45 90 triangle, because this should be 45 degrees. This is 45, this is 45. So we have 45 90 triangle. From our 45 90 triangle theorem, it states that if you have a triangle that the angles are 45, this is 45 degrees, this is also 45, that the hypotenuse is just x times root 2 as far as these angles are 45 degrees. So that's the first thing we'll know. Secondly, since this triangle and this triangle are the same, they are the same, which makes this area, the area here, to be the same as this. So if we shade here, assuming we decide to shade you see that the area of this 4 shaded region, that's the one given and the one I added here, is the same as the area of the circle minus area of the square. Yes, if you want to find the area of the 4 shaded regions, that because they are equal, they are all equal, is the same as subtracting the area of the square from the circle. So I'm saying that, okay, maybe let's call, if we call here A, call here A, they are all equal. This is also A, this is also A. We can easily see that we are saying that area shaded is equals area of circle minus area of square, and we need to get the area of the circle in terms of the side of the square, because we are looking for the area of the square. So from what I just explained, 45 90 triangle, you can easily see that from this triangle, that 2r is the same as x times root 2. Yes, from what I just explained, this is x, this x, so 2r is the same as x times root 2. So making r the subject of formula, we have that root 2 over 2 x, yes, which is the same thing as x over root 2. I would prefer using this x over root 2. So we now go over to this to get the area. Area is now area shaded, I told you they are the same, so it's like 4a is equal to area of a circle is pi r squared. So our r is x over root 2, so we have pi x over root 2 squared minus area of a square is x squared. So, and we are given only two parts, so this is now 2 times 10 pi, because out of 4 we are given 2, so remaining 2. Do you get 4a means 2 times 2a, because a plus a is 2a, so, and 2a is 10 pi, we are given 2 as 10 pi. So why this is now x squared over 2 pi minus x squared. X squared root 2 squared is 2, so pi. So we have 20 pi is equal to factor x squared, which is pi over 2 minus 1, and pi over 2 minus 1, pi over 2 minus 1 is pi minus 2 over 2 x squared. Do you get pi over 2 minus 1 is pi minus 2 over 2? Why this x squared is this? So we'll cross multiply, so we have 40 pi over pi minus 2 is equal to x squared, which is the area of the square. The area of the square, because the side is x, so the area is x squared. That is what we are asked to find. The answer is option D. So it's a very tricky question, option D.
So we're asked a circle and a square are inscribed in a square of area 64 cm square. Find the area of the shaded region. So before I solve it, let's look at these two diagrams. So if you notice, it's the same thing as the former diagram, but they are now together, because we have a circle inscribed in that square, the bigger square, and also the smaller square inscribed in that. So just know that whenever you inscribe a circle in a square, that the radius of that circle is half of the side length of the square. Yes, because as you can see, if this is the middle of this circle, tracing down, this is the radius. Also tracing is also radius, and this FH is equivalent to BC. So note that the radius is half of the side. Why here? Whenever you inscribe a square in another square, the ratio of the area is 1:2, meaning the ratio of the side is 1:√2. Yes. Okay, the easiest way to picture that, you know, this is a square, this is 90, this is the middle, because for you to inscribe the square, it must be the middle. So all these are the midpoints. So if you call here x, here is x, remember here is 45 degrees, here is 45. So making here to be x times √2 by 45, 90 triangle theorem. And here is x. So what do you notice? The total length of the square is 2x. So if you check the ratio, is now 1:2. So that's the knowledge I'm going to use here. Okay, coming to this question, you see that remember they said the area is 64, so meaning the side is 8, so here is 4. Why this is 4 root 2 with what I just explained, that the ratio whenever you inscribe a square, the ratio of their side is 1:√2. So we are now done, and remember they shaded 1 out of 4. This is 1, 2, 3, 4. So assuming they shaded all, the area is just area of this circle minus area of this square, but they shaded 1 out of 4, so the area now is just, so the area shaded is 1/4 of area of the circle minus area of the in squared, not the circum square, the square that is inside. So we have 1/4. Area of a circle is pi root square, so pi 4 squared minus area of the square is 4 root 2 all squared. So we have 1/4. As you can see, this is 4 squared. Okay, let's just write 16 pi minus this 32. That's 4 squared, 16 times 2. Okay, so this is 1/4 times 16 is 16 pi is 4 pi minus 10 times 1/4 times, that is 8. So our answer is 4 pi minus 2. So option A. So it's very simple. Okay, we are given the diagram and we are asked a circle is inscribed in a square as shown. If OB is 3 root 2 cm, then the area of the shaded region is dash. Okay, so what I will do, I'll first join F to H. I'll join F to H. So once I joined it, you can see that will form a rectangle FBCH. Rectangle FBCH. And assuming we shaded this region, assuming this part of the region shaded, you will notice that the area of the shaded region, that's here, here, and here, is the area of the rectangle minus area of the semicircle. That's it. But we are given just this and this, and since the center of the circle, this is the center of the circle, and this is the vertex of the square, that's the big square. So you see that this line OB is an angle bisector, yes, because it passes through the center of the circle, or it is from the vertex of this small square. So I'm saying that this angle is 45. This angle 45 here is 45 degrees. Here is also 45. So since OB is 3 root 2, this should be 3 and 3. Yes, this is 90. So this is 45. So this is 3 and 3 for OB to be 3 root 2 using 45, 90 triangle theorem. Yes. So we now have a rectangle of side. This is also 3 of sides 3 and 6. Why we have a circle of radius 3 cm. So what we are looking for is the area. Therefore, so I'm saying that FB is 3, which is the radius of the circle, by 45 90 triangle theorem. Therefore, area shaded is equal to, I told you that assuming we shaded this region, the area of the shaded is area of the rectangle minus area of the semicircle. But they didn't give us this part. I just say let's shade this so that we can see what is happening. So meaning that the area shaded now is now 3/4, because assuming I join O to C, it will also bisect this shaded part into 2 equal parts. So we have like 2 of them, 1 2 here and 1 2, that's 4. But we are given 3 out of 4, so we have 3/4 of the total area. Do you get the logic? 1 2, assuming I still join O to C. Okay, maybe let me join it. So do you see it? If I've joined OC, so we have 1 2 3 4. So but out of the 4 we are given 3 except this. So that's why I did 3/4. So that with that it's now easy for us to solve. So we have 3/4. Rectangle, the area is 3 times 6. That's 3 times 6 minus area of a semicircle is half pi r squared, and the radius is 3, so 3 squared. So we have, this is now 2 and this is 3, so 3 times 3 9, 9 times 3 27. We have 27/2 minus, so this is now 9 times, that's 27 pi over 8. But we don't have something like that, so meaning this they substituted pi as 22/7. So I have 27/2 minus 27 times 22/7/8. So this is 27/2 minus is 2 11 times 27 is 297. 4 times 7 is 28. So the LCM is 28. So 27 times 14 is 378 minus 297. So which is 81/28. So that is our answer, cm squared, which is option B. So it's a very simple question but tricky. Thank you. Okay, I said a circle is inscribed in a square as shown. If BD is 6√2, then the area of the shaded region is dash. Okay, you know BD is the diagonal, so and this is a square, so this B, C and C, they are congruent. So I'm saying that from here to here, from here to here, the length is 6 by 45 90 triangle theorem. Yes, the angle here is a square. So since BD is the diagonal, which is 6√2, these two must be 6 because this is
45 is an angle bisector. 40. So that's it. So the side of the square is 6, and as you can see again, this is 3. DH, each of these is 3, so this is square of 3. So if you join this, you notice that there are 3. Yes. So what do you have to say? You know, this is a square, and the shaded region, this region, this and this, they are the same. So what do you do? This is just half of the total. Do you get? This bisect this into 2 equal parts. So this and this are the same. So shading here is the same as this, which is the same as this. So what we have to find is just the area of this, or the area of the shaded this part, or this, which is the area of the square minus area of the sector. So I'm saying that therefore the area shaded is just area of this small square minus area of a sector. Yes, from here the area is 3 squared minus this is a sector. You know, this in this the angle here is 90. That's 90 is a square now. So this is 90 over 360 times pi r squared. This is a sector. 3 squared. So which is 9 minus 9 over 9 pi over 4. Okay, nothing like that. So since they substituted, pi is 22 over 7. So 2, so we have 14, 9 times 99. Yes. So we now have 9 minus 99 over 14 is 27 over 14, which is option B. So it's a very nice question. But the areas here, 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 and here are the same. The areas here, 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 and here, they just cut the half and place in this side, so they are the same, just the area of that region. The shaded region is bounded by length BA, length BD, this is a straight line, and finally an arc AD. So that's what we are asked to find. So we are asked the perimeter. Okay, let's just joining the radius. That's O to D is the radius, which is 6. We know that the radius is always perpendicular to the tangent line, and here is 120 by angle on a straight line is 60. Finally here is 30 degrees. So we need to get BD and BA. Remember, here is also 6 by what we call 30 60 90 triangle theorem. The theorem is simple to understand, that if you have a right angle triangle with interior angle 30 60 90, that if the one opposite 30 is x, the one opposite 60 will be x times root 3, while the one opposite 90 is 2x. So using that logic, the one opposite 60 here is 6, so the one opposite 30 will be 6 over root 3, which is 2 root 3. While the one opposite 90 is double of this, double of the one opposite 30. So BO
BO is 4 root 3, but we have 6 here, so this should be BA is now 4 root 3 minus 6. So finally we need to get the length of arc AD minus arc AD. So we see that arc AD minus arc AD is, remember, length of arc is theta, which is 30 degrees over 360 times 2 pi r. As you can see, this is 12, so we are left with pi. So the length of arc is pi. So as you can see, we are asked to find the perimeter of the shaded region, and the perimeter is BA plus AD arc AD plus BD, and BA, as you can see, is 4 root 3 minus 6. Arc AD is pi. Finally, BD is 2 root 3. 4 root 3 plus 2 root 3 is 6 root 3 minus 6 plus pi. So that's the answer. So the answer is option B. Whereas find the area of the shaded region if the radius of each circle is half. So as you can see, we have 4 congruent circles, and the best way I will find the area of this shaded region is by joining the radii. So assuming this is the center of the circles, so if we join the centers, so the radius, okay, for after, let's just use r for now. After we substitute so that it will be easy, like getting a formula for something like this. You know, this is 90, this is 90, this is 90, this is 90. So the area of the shaded region is the area of this square of length 2r plus the area of the major sectors. We have 4 major sectors, which each angle is, remember, this is 90, so each of these should be 270. This is 270, 270, finally 270. So let's find our area now. Area is now the sum of, so we now see that area shaded is area of the square plus 4 times area of the sectors, one sector, major sector, because they are all congruent sectors. So we have area of a square is length squared, so we have 2r all squared plus 4 times area of one of the sectors, major sector, which is 270 over 360 times pi r squared. Remember, okay, pi r squared. So we have 4r squared here, and we have 0 is 3, 9 in 36 is 4, so we have 3 over 4 pi r squared. So this is 4r squared plus 3 pi r squared, and they told us r. Okay, let's factor the common terms. We have r squared, so we are left with 4 plus 3 pi. So the r is half, the radius is half, so therefore the area is 1 over 2 squared times 4 plus 3 pi. So we have 1 over 4. 4 plus 3 pi. So okay, the answer is not. Let's open up the brackets. Half 1 over 4 times 4 is 1. 1 over 4 times that is 3 pi over 4. So the answer is option A.
Of shaded region. Okay, from the diagram you see that the shaded region is the same thing as the area of this triangle minus area of these two sectors, and you see that the sides are all 8 cm, so it's an equilateral triangle, making each of the interior angles to be 60 degrees. So we now have that area shaded is equal to area of triangle ABC minus area of the two sectors. The sectors are congruent sectors, the same measure. So, and we know that area of an equilateral triangle is √3 over 4 sides squared, and the side is 8, so 8 squared minus area of a sector is theta over, which is 60 over 360 times pi r squared. The radius is 4, as you can see. And remember, we have 2 of them, so we multiply by 2 because they are the same. So this is 64 and 4 is 16, so I have 16 √3 minus this is 120 in 363. So 4 squared is 16, so 16 pi over 3. So our answer is option B. Let's find the area of the shaded region. As you can see that's the diagram. This shaded region is the same thing as subtracting the area of these sectors from the area of the triangle. So I'm saying that area shaded is area of triangle ABC minus area of the 3 sectors. And again, there is one important feature here. The length of sides are the same, 8 cm, making it an equilateral triangle. So we have each interior angle is 60 degrees. 60. So, and there is a special formula for area of an equilateral triangle, which is √3 over 4 times side squared. So the side is 8 cm, so 8 squared. So that's the formula for area of an equilateral triangle minus area of a sector is theta over 360 times pi r squared. So the angle is 60 over 360 times pi r. Our radius is 4. But this is just the area of one sector, so we'll multiply by 3 to have the area of the 3. But they are congruent, 4 cm 60 degree, 4 cm 60 degree. So 64 in that is 16. So I have 16 √3 minus this is 180 in 362. 4 squared is 16. 2 in 16 is 8. So we have 8 pi. So our answer is option C. Find the area of the shaded region given this diagram. As you can see, the shaded region is made up of a major sector and part of the triangle. So what I will do, okay, let's label this G as sector EGF. So we see that okay, this, as you can see, this 8, the length 8a, so it's an equilateral triangle making each interior angle 60 degrees. And since this is 60, the angle of the major sector is 300, that's 360 minus 60. So now we see that area shaded is the same as area of the sector as EGF plus area, this area, and this area is the same thing as area of the triangle minus area of the two sectors, congruent sectors. And the area of a sector is theta, the angle is 300, so 300 over 360 pi r squared, or r is 4, so we have pi 4 squared plus area of a triangle. Since this is an equilateral triangle, the area is always root 3 over 4 times side squared, and the side is 8, so we have 8 squared minus the sector. Remember, they are the same, so we will find the area of one and multiply by 2, so 2 times 60 over 360 times pi r squared, which is pi 4 squared. So we have 6 here is 5, 6, so we have 5 over 6 pi 4 squared plus 8. You can write 8 as 4 times 2, so we have 4 squared times 2 squared, because 8 is 4 times 2, minus this is 120 and 363, so we have pi 4 squared over 3. And looking at all this, we have common factor 4 squared, so bring 4 squared, we are left with 5 pi over 6 here. We are left with, remember we brought out 4 squared, so 4 and 4, so we are left with 3 here, and minus pi over 3. 5 pi over 6 minus pi over 3 is 3 pi over 6, and 3 pi over 6 is pi over 2, so we are left with 4 squared is 16. We are left with root 3. This is root 3. Why the sum of this is over 2? We get 3 pi over 6, which is pi over 2. So once we open up this, the answer 16 times root 3 is 16 root 3, and 16 times pi over 2 is 8 pi. So our answer is option C. If A and B are the centers of two congruent circles of radius 6 cm, find the area of the shaded region. So the first thing I will do is to add some auxiliary lines so that the equation will be easier for us to solve. So I've added that. So we notice that we'll form two equilateral triangles since they have the same radius. So these are all the same, and each is 6 cm. Since we have an equilateral triangle, meaning that the interior angles are all 60 degrees. And from there you see that this area and this area are the same segment, sorry. This segment and this segment are the same. So meaning that if I want to get area of the 2, I just find the area of 1 and multiply by 2. And how do I get one of the areas? I will subtract the area of this triangle, equilateral triangle, from area of the whole sector. So we see that the area that we are looking for, area shaded, is now equal to area 2 times area. Okay, area of the sector minus area of the equilateral triangle after you multiply by 2. So area of the sector is, we know that is theta, which is 60 over 360 times pi. The radius is 6, so 6 squared, pi root square, minus, we have special formula for area of an equilateral triangle, which is root 3 over 4 times the side squared. The side is 6, so times 6 squared after we multiply by 2. So what we have here is 36, 0, so we have 6 pi minus this 36 over 4, 9, so 9 root 3 times 2. So we now finally we have 12 pi minus 18 root 3 cm squared. So that's our final answer, option A. So it's a nice question, very tricky.
These are the centers of the 3 congruent circles as shown. We have to find the area of the shaded region. So we're going to use a formula, a general formula for something like this. So if you have 3 circles arranged like this, remember they must be congruent. That the area shaded, the area we are looking for, is always a 3 minus I over 3 times r square, where r is the radius. The radius, so from the diagram, the radius is 7. So I have 3 minus, since there is no pi in the option, so we use 22 over 7, so I have 22 over 21. 7 times 3 is 7 squared. And that gives us 14 over 3 minus 154 over 3. Yes. So that should be option B. So let's prove the formula. So as you can see, they have the same value. So for us to get this area, we subtract this area of this and this from the area of the circle. That gives us the remaining. And that's what we are looking for. Added the auxiliary line. So how, remember what I said, for us to get this, we subtract the area, this area, from area of the circle. Oh, but how do you do to get the area, this one? So that's why I added this auxiliary lines and the radius. So these are all the radius of the circle, so they are equal. Radius of the circles. So each of them is r. All equal. So first of all, I told you the area shaded is now area of the central circle, this one, which is pi r squared minus. So to get this one, you have 4 equilateral triangles, so 4 times 3 over 4 r squared. So each of the areas with 3 over 4 r squared. Plus, we have 8 segments, yes. See the segments, let me shade this so you see. These parts. So these are all the segments, so we have 8 of them. So, and 8, the area of one of them is area of the sector, you know the sector, minus the triangle, area of the sector. I'm using this when I want to get this, the area of the sector minus area of the triangle. So this is sector is area is theta, because remember it's an equilateral triangle, each of the interior angle is 60. So I have over 360 times pi r squared minus root 3 over 4 r squared. So that is and this is now equal to pi r squared minus 3r squared minus 4 over 3 pi r squared minus times multiply plus 2 with 3r squared. Yes, and this is now 2 3r squared minus 3r squared is 3r squared. Y pi r squared minus 4 over 3 pi r squared is 5 over 3 r squared. You can factor r squared, so we have to do 3 minus 5 over 3 all times r squared. That's the formula we use. So we don't need to waste this time. So long as an OBJ question. So you can apply this formula, just try and memorize it. Thank you.
See. So it's a very nice question. Thank you. We're asked what was the area of the shaded region if the quadrilateral is a square. Okay, I will solve fast using a formula. Whenever you are given a square and we have this, this is like a quarter circle and this is also a quarter, so they are common region. Whenever you are asked to find the area, that the area is equal to area of the shaded region is equal to 4 over 7 a square, where a is the side. Yes, so that's the formula. So from this you see that the answer is 28, because this is 4 times 7 times 7 square, which is 4 times 7. So the answer is option A. So do you see that it's fast? Let me now prove how I got this formula. So we have the same diagram and we're asked to find the area of the shaded region. So if we call the side of the square, let's call it A. So I will join this end, maybe let's name it A B square, A B C D. So let me join B and D. So I've joined, let me use white. Sorry. Okay, let's call this A1 and here is also A1. These two areas are the same, and for us to get, meaning that the area of this shaded region is 2A1, and if you look at this triangle, we have a sector. This is a square, so each of this interior angle, each interior angle is 90 degrees. So we now have a sector. We have sector CBD and we're asked to find A1. So it's the same thing as subtracting the area of this triangle from the sector. Yes. So you see that A1 is equal to area of the sector minus area of the right triangle. Yes, as you can see, this is a sector. So if you subtract the area of this triangle from that of the sector, we'll get A1. So an area of a sector is 90 over 360 times pi A squared minus, and this is a right angle triangle, so half base times height, that half A times A, so which is now equal to pi A squared over 4 minus A squared over 2. And we can factor what is common in both is A squared over 2. So if we factor A squared over 2, we are left is pi over 2 minus 1. Yes. and pi is 22 over 7. So we have a squared over 2. 22 over 7 is now 11 over 7. Do you get? Pi is 22 over 7. So 22 over 7 over 2. 2 and 22 is 11. Minus 1. Which is now equal to a squared over 2 times 11 over 7 minus 1 is 4 over 7. 4 over 7. This is now 2 over 7 a squared. So from this you now see that the area shaded is 2a1, which is 2 times 2 over 7 a squared. So that's how I got 4 over 7 a squared. So that's the formula I use in solving this fast. So it's very easy. Thank you. Okay, we asked find the area of the shaded region. Okay, I will use a fast as a formula that whenever you are given this kind of diagram, as long as this is a quarter circle, that's the length here and here are the same, we use this formula that assuming we'll call this area A and we'll call this area B. A is equal to B, yes. I will still prove it. So this area and this area are equal, and both are equal to 4 over 7. The length here, half of it, that is 4 over 2 squared. So we have 4 over 7 times 2 squared. So which is 16 over 7. So A and B are equal to 16 over 7, which implies that A plus B, because that's what we are asked to find the area of the shaded region, is now 2 times 16 over 7, since both are equal, which is 32 over 7. So the answer is option B. So that's the first one. So let me now prove how I got this formula as A and B to be equal to 16 over 7. Okay, this is similar to the former diagram. So first I will prove that I will start with B, that B is equal to 4 over 7, half of the length here. So if we call this length, as you can see, these two semicircles and they intersect at this point, it shows that this is the middle. So the middle will be here. That's the center of this semicircle and this. So if we join, okay, maybe call this A, B, C, D. Let's call here E, and let's call here F. So let's join E to D and D to F. We've joined that. So if we call here, let's call this length BE, the radius, which is A. So this is also A, this is also A, this is also A, or you use radius, anyone. As you can see, if we want to get this area, that's area of B, is the same as subtracting this is 90, this is a straight line. It's the same as subtracting these two quarter circle with the square from the sector, the bigger sector. So if we subtract this area from this sector, that's B. So I'm saying that to get B now is equal to area of sector, that's the bigger sector ABC, minus the sum of the areas of the square, that's EDF A plus sector EBD and sector DFC. So once we subtract this area from the big one, that's B. So an area of a sector is theta, that's 90/3 is a quarter circle, so 1/4 pi a squared. Sorry, 1/4 pi 2a all squared. Yes, that's area of this big sector. The radius is 2a. The angle is 90. 90/360 is 1/4 minus area of a square. You know, this is also a. So which is a square, that's area of this square, and this is a quarter circle. So if you join the two, it's now semicircle. So let's not waste time. So it's now half pi a squared. Do you get this? 1/4. 1/4 plus 1/4 is 1/2. So as you can see, this is 4. We have pi a squared minus a squared minus half pi a squared. And pi a squared minus half pi a squared is, okay, let's just continue here, is now half pi a squared minus a squared. And we know pi is 22/7. So pi is now half times 22/7 a squared minus a squared. This is 11/7 a squared minus a squared, which is now equal to 4/7 a squared. So have you seen why I said that the area of A and B is 4/7? A is half of this length. That's why I divided by 2. So if you compare it with this, you see that A is half of 2A. So we've proved that. Next thing is to prove that this diagram, that's A, is equal to B, but I will use a different diagram. Let me use another diagram. So we have the same diagram, and we're asked to find the area of the shaded region. So if we call the side of the square, let's call it A. So I will join this end, maybe let's name it A B square, ABC D. So let me join B and D. So I've joined, let me use white. Okay, let's call this A1, and here is also A1. These two areas are the same. And for us to get, meaning that the area of this shaded region is 2A1. And if you look at this triangle, we have a sector. You know, this is a square, so each of this interior angle, each interior angle is 90 degrees. So we now have a sector. We have sector CBD, and we're asked to find A1. So it's the same thing as subtracting the area of this triangle from the sector. Yes. So you see that A1 is equal to area of the sector minus area of the right triangle. Yes, as you can see, this is a sector. So if you subtract the area of this triangle from that of the sector, we'll get A1. So an area of a sector is 90 over 360 times pi a squared minus, and you know this is a right angle triangle, so half base times height, that half a times a, so which is now equal to pi a squared over 4 minus a squared over 2. And we can factor what is common in both is a squared over 2. So if we stop factor a squared over 2, we are left is pi over 2 minus 1. Yes. And pi is 22 over 7. So we have a squared over 2. 22 over 7 is now 11 over 7. Do you get? Pi is 22 over 7. So 22 over 7 over 2. 2 and 22 is 11. Minus 1. Which is now equal to a squared over 2 times 11 over 7 minus 1 is 4 over 7. 4 over 7. This is now 2 over 7 a squared. So from this you now see that the area shaded is 2a1, which is 2 times 2 over 7 a squared. So that's how I got 4 over 7 a squared. So that's the formula I use.
We're asked ABCD is a square of area 1 cm squared. What is the area of the shaded region? Okay, I'm going to solve it fast using a formula, and after I will prove the formula. So to solve anything of this form, once is a square with this part shaded, the area of shaded region is always equal to a squared over 12 times 3 root 3 minus pi. So that's the formula, where a is the side. So whenever you have a square with side a, the area of this part shaded is always a squared over 12 times 3 root 3 minus pi. So as you can see, a is the side, so a square is the area, and they give us the area as 1, so it's 1 over 12 3 root 3 minus pi. So that's the answer. So option C. So that's a very nice question. Okay, let me now prove how the formula came about. Okay, look at this. It's the same as the previous question, but here we are given the side as A. Whereas ABC is a square, what is the area of the shaded region? So the first thing I have to do is to join some parts. So let's join D, K, and C. Let's join. So we've joined
D to K and C to K. And if you notice, this is like a quarter circle, as DAC is a sector, that's a quarter circle. Now also this is also a sector, a quarter circle. This is a square, so the angle, interior angle is, each is 90. And again, you can see that from here to here is also A. Yes, that's like the radius of this quarter circle. And if you look at this quarter circle BCD, you also see that here is also A. So this is the radius. And we also have A here, making each of these interior angles to be 60, because this is an equilateral triangle. Remember, since this is a square, means that the remaining angle here must be 30 degrees, so that it will sum to 90. So from this, you can see that this area of this shaded region, let's call it A, is equal to the area of the sector minus the area of this segment. So let's call it A1, this is 8. So if you subtract A2 from the area of the sector CBK, that's what we are looking for. This is a segment. So for us to get is the area of this sector D KC minus area of the triangle. So that's it. So from here we can see that the area shaded is equal to area of sector CBK minus A2. Yes, once you subtract A2 from A1, that's where it, but A2 is equal to area of sector DKC minus area of triangle DKC. Let's get this. This is equal to sector. We have 60 over 360 times pi a square. That's area of a sector minus area of the triangle. This is an equilateral triangle. We have a special formula which is √3 over 4 side square, and the side is A. So area of equilateral triangle is always √3 over 4 times the side squared. So we now substitute it. Therefore the area shaded is equal to area of sector CBK. So we have 30 over 360 times pi a square minus A2, which is this, which is 60 over 360 times pi a square minus √3 over 4 a squared. So as you can see, minus times this is √3 over 4 a squared. I'm solving from the back because I want to subtract this from this. So this times this is this. So 30 over 360 is 1 over 12. While 60 over 360 is 1 over 6. 1 over 12 minus 1 over 6 is minus 1 over 12. So pi a squared, which is the same as, we can find the LCM. The LCM is 12. And this in this 3, so 3 √3. Why this in this is 1 minus pi. So what is common in both is a squared. A squared is common, you bring it out. 12 in this 3 times that, you get this 12. So that's how I got the formula. Is
okay, we're asked to find the area of the shaded region if ABCD is a square of area 1 cm square. Okay, I'm going to solve the question very fast by using a formula. So if you have a square of side A and we're asked to find the area of this shaded region, the formula is always area shaded is all 12 minus 3 root 3 minus 2 pi over 12 times a squared. Yes, where a is the side. So from here they said the area is 1, so a squared is 1 because the side is 1. So the area is 1, as you can see. This area of this square, a squared. So the answer is 12 minus 3 root 3 minus 2 pi over 12. So option B. So do you see it is very easy to use. So they said ABCD is a square. What is the area of the shaded region? Okay, this is a square of sides A. And we're asked to find the area of this shaded region. For us to get the area, what we have to do is to subtract the remaining area, that's this part A, F, B, C, D, from that of the square. And to solve it this way is hard. So what I will do is to join some point. I will join D to F and C to F. So I've joined that. So it's now easy for us to solve because we have an equilateral triangle. Yes, this is an FDC is an equilateral triangle because looking at this is a quarter circle and this is also a quarter circle. And is a quarter circle of radius A. Yes. Look at. So meaning that DF is also A and CF is also A. Do you get? If you look at this quarter circle, this is A. This is the center now. So this the radius. This is also the radius. This is also the radius. So that's same way in the other quarter circle. This is the so we have an equilateral triangle of side A, which means that each interior angle is 60. Each interior angle is 60. And remember, this is a square. This is a square, meaning that this is 30 degrees. The remaining angle is 30. So we have a sector, two sectors, an equilateral triangle. So once we know the areas of the two sectors and the equilateral triangle, you add and subtract the area from that of the square. So let's get the areas of the sectors first. So let's call this A1, this A2, while this sector A3. So these are the three remaining areas. Once you subtract the areas of these three parts from that of the square, that gives us this. So let's start with, A1 and A3 are the same. Yes. So we see that A1 is equal to A3, which is now area of a sector. This is a sector of central angle 30 degrees. So we have 30 over 360 times pi A squared, because the radius is A. So we now have pi A squared over 12. And area of the equilateral triangle is a special formula for area of an equilateral triangle, which is root 3 over 4 side squared. The side is A, so A squared. So that's the area of the equilateral triangle.
Therefore, the area of the shaded region is now area of the square minus the sum of A1, A2. So which is area of A squared is A squared minus area of this sector. You know, this and this are the same. So let's do A1, so which is, I'm adding A1 and A3 straightforward. So we have 2 times pi A squared over 12. That's area of A1 and A3. They are the same. So you can see a sector with the same radius and central angle plus A2 is now root 3 over 4A squared. So we have what is common. You can see 2 here is, that's pi. Okay, let's just write one more time. A squared minus this pi A squared over 6. Why this is root 3 over 4 A squared. Therefore, the area we are looking for is now, which is equal to, you know, the LCM of A squared is common in all, so factor A squared, and the LCM of 1, 6 and 4 is 12, so over 12 in 1 times 1, 12, so we have 12 minus 12 in 4, 3 times that is 12, minus 3 root 3 minus 12 in 6, 2 times that is 2 pi. So that's the formula that I use in solving the equation first. So wherever you see this, that's the formula for the area of the shaded region. Okay, we're given square ABCD of side 1 cm and we're asked to find the area of this shaded part. Okay, the easiest way to solve this is to subtract the area of this part, that's this part, from that of the square. And if we can get the area of one, if you notice, we have 4 congruent areas. 1, 2, that I'm talking about C, B, G, H, A, B, D, H, C, and finally D, C, F. So once we subtract this area from the square, what is left is what we are asked to find. Okay, maybe let me shade it. So if we remove this area, if you notice this and that the same. If we remove this area, and finally if we remove this area, from the square, so that's what we are. And I'm going to solve it first, but I will prove the formula I will use now. So if we call the area here if we call it A, okay, maybe let me. If we call it A, the area, this, they are the same, also the same, and also the same. So do you see it? We have 4 areas that are the same. So if you know the area of one,
I'm going to prove that the area here is equal to a squared over 12 times 3 root 3 minus pi. I'm going to prove it where a is the side of the square. I'm going to prove it. So we have 4 of them. Therefore, the area we are looking for, which is this B, area shaded, is now equal to area of the square, which is a squared, minus 4 of this, as you can see, CBG, BAH, ADE, and finally DCF. Do you see it? So minus 4 times a squared over 12 times 3 root 3 minus pi. So we can see that it is equal to a squared 4 minus 4 times, so we have minus root 3 a squared plus pi over 3 a squared. Yes, if you open up this, that's what you will be left. Minus times minus plus. So 4, 3. So that 3, see it down here. Why the 3 here? We are left with only root 3. So they see it. And they told us the side of this square is 1. Our area is now 1 minus root 3 plus pi over 3. So which is option A. So that's the answer. Option A. So let me now prove how I got this formula, because that's the major thing here. Once we know it, we've understood how I solved this. So let's move to the next diagram.
Whereas ABC is a square, what is the area of the shaded region? So the first thing I have to do is to join some parts. So let's join D, K, and C. Let's join. So we've joined D to K and C to K. And if you notice, this is like a quarter circle. As DAC is a sector, that's a quarter circle. Now also this is also a sector, a quarter circle. This is a square, so the angle, interior angle is each is 90. And again you can see that from here to here is also A. Yes, that's like the radius of this quarter circle. And if you look at this quarter circle BCD, you also see that here is also A. So this is the radius. And we also have A here, making each of these interior angles to be 60, because this is an equilateral triangle. Remember, since this is a square, means that the remaining angle here must be 30 degrees, so that it will sum to 90. So from this you can see that this area of this shaded region, let's call it A, is equal to the area of the sector minus the area of this segment. So let's call it A1, this is 8. So if you subtract A2 from the area of the sector CBK, that's what we are looking for. This is a segment. So for us to get is the area of this sector D KC minus area of the triangle. So that's it. So from here we can see that the area shaded is equal to area of sector CBK minus A2. Yes, once you subtract A2 from A1, that's it. But A2 is equal to area of sector DKC minus area of triangle DKC. Let's get this. This is equal to sector. We have 60 over 360 times pi a squared. That's area of a sector minus area of the triangle. This is an equilateral triangle. We have a special formula which is √3 over 4 side square, and the side is a. So area of equilateral triangle is always √3 over 4 times the side squared. So we now substitute it. Therefore, the area shaded is equal to area of sector CBK. So we have 30 over 360 times pi a squared minus A2, which is this, which is 60 over 360 times pi a squared minus √3 over 4 a squared. So as you can see, minus times this is √3 over 4 a squared. I'm solving from the back because I want to subtract this from this. So this times this is this. So 30 over 360 is 1 over 12. While 60 over 360 is 1 over 6. 1 over 12 minus 1 over 6 is minus 1 over 12. So pi a squared, which is the same as, you can find the LCM. The LCM is 12. And this in this 3, so 3 √3. Why this in this is 1 minus pi. So what is common in both is a squared. A squared is common, you bring it out. 12 in this times that, you get this 12. So